Our last questions are more calculus based. How do I optimize? Calculus, right? Derivative equals 0. And then what does my answer mean is really important, especially because we are in an applications class, right? We are all about what does this mean in the real world? What does it mean in this application to have this answer? Bring it back in context, interpret it. Because sometimes you get an answer that's like 13.3 people. You can't have 0.3 people. So it needs to be 13 people, right? So making sure you always bring it back in context to double check, am I doing this question, answering this question within the context of the situation? If you chose for this previous one to have your answer be 12.9, realize in the context of this situation, 12.9 as an X value would have meant that you cut in 12.9, which is more than half of this I mentioned. You would have cut out more in terms of X of this square than you had available to also then cut out from the other half, right? If you had 12.9 as a dimension, that goes over halfway. Since it goes over halfway, you would have cut out more. So in context, you would have realized 12.9 doesn't really make sense as a dimension to have here. 4.06 would. Those connections are really important. All right. We've run out of space, which is perfect because those are all the hints that I have to give you. These are the things that I ask myself when I go through a problem for the first time. These are the questions that I verbalize when I'm walking you through a problem the first time. I know the answer to these questions when I'm asking them. I want you to be used to and have a voice in your head that's like, oh, well, Megan always first says, do I understand this problem visually? Megan first says, oh, I should draw a diagram. Megan first says, oh, I should draw a graph and put it in my calculator. I want you to have a haunting memory of me in your brain saying, put it in your calculator, draw a picture. Because hopefully when it comes down to the time that you need to do this the best that you possibly can, that's going to help you figure out a problem. These are things that will help you and help problem solve with you, that'll help you problem solve through something that is hard, which is everything we do in this class. We're going to do one more referencing back to these questions, and then our next notes will finish the rest of these. We have two vertical posts with heights of 7 and 13. They're secured by rope going from the top of one to the point on the ground between the two posts and then the top of the other post. So it like goes from two posts down and then back up to another one. So we need to represent this visually, which is our first question. The distance between the two posts is 25. So first question, do I represent this visually? Do I understand this visually? So I have two posts. What's a post? It's a thing that goes up and down. So draw two things that go up and down. Then you have a rope. Oh, one is 7 and the other is 13. There's a rope that's secured by the top of one post to a point on the ground between the two posts. So here's the ground. And we have a rope that goes from the top of one to a point up between them. I purposefully drew it very far from the center because it doesn't tell me that it's halfway through, which means it's not halfway through. It's somewhere there. If I draw it close to halfway, I know that part of me will be always wanting to do, oh, it's halfway, so I can just divide the distance between the two posts by 2. No, it doesn't tell us that it's halfway, so we can't put it halfway. So I made sure to not draw it that way. And then it says it goes down to the point between the two posts and then to the top of the other post. So then it goes back up to the top of this post. That is this situation. There's a few things that we know that we can add here. First of all, that the distance between the two posts is 25. So I'm going to add that in. And then I know that these posts are hopefully perpendicular to the ground. It would be weird if the post was not perpendicular to the ground. Some might even say that some people would create a tourist attraction out of something that should be perpendicular to the ground but isn't. Like, I don't know, Pisa, right? So it's very weird to not have things be perpendicular to the ground when we've built it to be on the ground. So we can always pretty much assume that it is. Now I've represented every single thing that was given to me in this problem visually. I have the 7, the 13, and the 25 represented. I've pinned down those numbers and said, where do those numbers go on the diagram? I've represented 2 posts, vertical posts secured by rope, and I've represented all of them visually. I'm hopefully seeing a few things like, oh, right triangles, or like, oh, both of these are hypotenuses, right? So like hopefully visually understanding it is like giving you clues of like, oh, I wonder if this might be something that plays into this, or oh, I wonder if that might be something that plays into this. And notice we haven't even read what the question is yet. We've just represented the beginning part visually. When you first read this, when I first did this problem, I didn't even read the question. I just drew the diagram right away. And then I'm like, oh, I've got some Pythagorean theorem, maybe. Oh, I've got some like right triangle trigonometry, maybe. Oh, I've got some of this, some of that. I've got some ideas of relationships that I can bring in to attack my third step right here. But first, I'm going to attack my second question, which is, what am I trying to optimize? What equation am I trying to go for here? It says, how far from the base of the shorter post should the rope be anchored? Okay, so how far from the base? We're talking about the rope being anchored. If we're talking about the rope being anchored, we want to know this dimension, and this dimension could change depending on where the rope is. So this one's kind of hard to tell. And honestly, when I went through this problem, I was like, what am I trying to optimize? And then I had to take a step back and think about, well, the thing that's limiting me here, the thing that I am limited on is my rope, right? If I'm not limited on space in between, I'm not limited on the heights. Those are just already established. The only thing that's being manipulated here is how much rope I'm using. So if we want to talk about the rope, well, we've got, I'll call it X and Y. We've got an X length of rope here and a Y length of rope there. So, okay, we're probably talking about something with this rope that has that relationship, that it goes down and then back up. So the total rope that we're using is both of those together in an addition sort of way. So it says, how far from the base of the shorter post should the rope be anchored? I have too many variables, right? So this is problem number 3. I've figured out a relationship that says, okay, I'm probably going to try and minimize the amount of rope that I'm using here because I'm not made of money. I can only buy so much rope. And I've got this as a variable, an unknown, as well as X and Y. So I have 3 unknowns right now, which means I need to try and limit myself on these unknowns. Okay, well, I have this relationship of these dimensions right here. And I know that if I wanted to create relationships within this, I would maybe need angles to do right triangle trigonometry. Or, as I said before, like, oh, right triangles, maybe Pythagorean theorem. This is where maybe things can be a little tricky because we don't know how to represent this dimension. But what if I called this guy right here Z? Then this guy right here would be 25 minus Z. So then if I was trying to create relationships, create equations around this situation, I've now got Pythagorean theorem of, let's do Z squared plus 13 squared equals Y squared. I've also got 25 minus Z squared plus 7 squared equals X squared. Kind of like in our diagram before, notice I could replace Y with what's going on here, and I would be putting a Z in instead, which doesn't seem very helpful until I realize that I could also replace X with this situation that's going on here. And the variable I would replace, instead of having X in this situation, I would then have Z, which means both of these equations would eliminate X and Y and instead make it a function of Z. So I brought it down from 2 different variables to now 1 variable. So let me figure out a way that I can plug it in. Okay, well, I need to take the square root of both sides, and I've got the square root of Z squared plus 13 squared, and that's equal to Y. And then I've got the square root of 25 minus Z squared plus 7 squared, and that equals X.